Hello everyone and welcome to a new episode of the Icaerus podcast series. Icaerus is a European Union funded project aiming to explore how drones can serve multiple purposes in agriculture, forestry and rural areas across Europe. I am Alexia Mastora, Communications Manager at Reframe Food, a non-profit organization aiming to transform the agri-food sector through innovation and technology. Today, we have the pleasure to welcome Simonas Audickas. Welcome, Simonas, and thank you for being here with us.
It's a total pleasure.
Let's begin with our first question. What are the main challenges addressed by the use case titled Forestry and Biodiversity Monitoring with Drones?
Firstly, I would like to name that in this project, we are tackling three different issues. So one of them is forestry health, and which we apply and use the drones. And in this case, we also used satellite data and the data sciences to kind of sum up everything what we discover. So basically, we identify the insects and the potential areas where the insects are actually damaging the trees. And so the other case is that we evaluate the fire risk in the forest area. And another one, so we are monitoring the ecosystem or we are working with the wild animals, in this case the wild boars. So we monitor wildlife population and how they actually spread and to prevent the diseases that they might bring to the local our farmers animals. So the challenges, as you mentioned, so for us is forest cover vast areas, and that is difficult to monitor doing it manually if you do it on foot and going through the forest and getting the data. So this is what the drones actually allow us to solve. Central civic protection agencies do not have the capacity to monitor both flora and fauna in high spatial and thermal frequencies. And the third is a challenge, limited capacity to detect forest trees or the diseases in the trees, like as an outbreak, early outbreak. Wildfire prevention as a suspension requires almost accuracy and timeliness, so we need to know when actually to prevent the forest fires. And one of the big challenges is difficulty to prevent infectious diseases which are contagious from feral to domestic animals. So the solution, as mentioned, so we use the drone, and in this use case we demonstrate the potential of the drones to support forest and biodiversity monitoring. Tree health will be monitored initially using satellite imagery, so which we did already, so we have preliminary results. Then we make it more accurate results by using the drones over the same areas. Later on, so fire risk prevention will be, and it is targeted by utilizing meteorological data and drone imagery analysis to detect the presence of materials that can spark wildfires and identify high-risk areas. And finally, so as mentioned, with the help of the drones with the mounted thermal camera, we are using to count and analyze the behavior of migrating wild boars infected with African swine fever in order to prevent mixing the local boar population and disease expansion into local farmer, local animals like pig farms.
That was a very insightful overview. It is clear that drones are playing a vital role in addressing both environmental and animal health challenges. Are these issues specific to the regions you are working in?
Not very specific, I would say. Tree health and fire fuel investigation are very relevant to Lithuania forest, which is nowadays, and as we've seen in Los Angeles fires, big fires. So they are spreading using any type of wood, but we kind of specifically now work with the pine trees. And investigatory process and research can be applied in any country, so it's not our local Lithuanian forest specific where the pine trees are going, but it can be applied to any type of wood, like I don't know, olive trees per se, if we would use it in Greece. Well, investigating wild boar monitoring is somewhat is a challenge in Lithuania, as after the swine flu pandemic, the wild boar population is starting to regain pace. And this is somewhat of a challenge or a problem that people foresee might cause a little bit, like the result might cause come a little bit later. So it is difficult to research and to observe the herds of the boars. And we are not investigating the olive trees, as I mentioned, but that's why it's like for us what we have at hand, so we do it. And basically our modeling, it can be applied in other regions as well, so it's not very region specific, but it can be adopted to tackle other issues in other regions as well.
Thank you for sharing that. Now let's take a closer look at the practical impact of your team's work in the field. Could you describe the work being carried out and its impact? Have there been any significant findings so far?
Mm-hmm. Well, it's a bit, as mentioned with the satellite data, we have some results, but it is early to say whether those findings are very significant and in our use case. But we want to sum up everything within the project, and we have certain research results. But we had the presentation of the use case methodologies and possible results to the forest rangers in Lithuania, who have confirmed that the technology constitution and the preliminary results would save time, provide much more accurate results for the decision-making procedures, and will contribute to prevent deforestation, because they kind of cut off the affected areas in the forest, and those forest cuttings, so they kind of don't want to cut, but they are necessary to prevent the spread of the forest insect infestation. So basically what they confirmed that as well with the fire fuel detection modeling, which allows fast reaction to the forest rangers to prevent much bigger disaster, as we've seen, as I mentioned, in Los Angeles and other countries. And this means that we can prevent the loss of biodiversity and wood as material. Yeah, so basically we have kind of confirmation from somewhat stakeholders, but we are working further to make sure that it would be really tackable problems, and the technology wouldn't cost millions, actually, that it would be affordable to the users.
Although, as you mentioned, it is still early to speak about significant findings. It is encouraging to hear that this kind of technology holds strong potential. Could this approach also be applied beyond your current region?
The methodologies and AI modeling can be applied for other European countries, other types of forest, and of course other types of wild animals, such like deers and bisons and others. Adjusting the AI modeling, it can be retrained to do researches on, let's say, animals like wolves, deers, bisons, and other cattle. Maybe also local farmers could count their sheep and cows in the field. Not to mention that additional data will have to be collected, of course, to retrain the models actually to be applied. But what we see that what we work on, so that it can be adoptable in other regions, other cultures, other trees, other animals as well. So yes, so the findings can be scalable to other possible applications.
That was a point worth highlighting. Let's now make a more technical turn. What kind of drones make this work possible, and why were these chosen?
Okay, so at the moment we are using the octocopter drone called Aurelia X10, which has a lifting power of 4.5 kilograms, and we chose it because of the possibility to carry quite heavy cameras underneath. And thermovisual and hyperspectral cameras that we use in our use case are attached at the gimbal for the stability and to take the clear pictures, and which is directly attached to the drone. So which means that the camera, like the hyperspectral camera, is quite heavy, and it needs to have stability. So the other reason of high visibility at night for the thermal camera and the capability of flying cold weather conditions, and as we do for the wild animal research, and usually it takes over the night to have the distinction between the weather conditions and the warmer animals. So basically, yeah, our drone, and one of the reasons as well, so that the bigger drone, it allows us to cover the bigger areas, so of the forest, or to find the animals. So we have to fly quite big distances with the drone to actually find the animals and to collect the data that we need.
It's fascinating to hear how specific equipment choices are linked to your research needs. Besides drones, are there any other technologies that support your monitoring effort?
Yes, we started our research by investigating the satellite data, as mentioned before, and we kind of have used different indices for the forest to see which areas are affected by insect infestation in the bigger forests. So we used the satellite imagery, and this was done with the specific indices as mentioned, which reveal the trees which are under stress, and it actually shows us what like the areas or which pine trees are affected. And later on, to measure the magnitude of the and the accurate territory, so we lift up the drone with the hyperspectral camera, the imagery, so we collect the data which is more specific, and the pixel size is much smaller, so we know and we can see much more accurately from the shorter distance, not the satellite.
It is clear in a way that combining satellite images with drone data enhances the quality of your work.
Yes, that's correct.
Yes. However, every project often brings surprises. Have you faced any unexpected challenges, and how did you manage to overcome them?
Well, the biggest predicted challenge was weather conditions. You cannot use drone in the damp conditions, which makes data collection scarce, rather unpredictable. So during the year we are planning to collect data within certain months, but apparently if the rain falls within those months, so we are not able to carry out the research and collect the data. So to overcome this, we had the scheduled flights, and we work around the schedule with some times of the delay. But we allow ourselves to have those gaps of the snowy and rainy conditions. And another issue was, well, coming back to this, so we have to have a quite quick reaction time by the drone operator, so that if like during half of the day we see that weather conditions allow us to pick up the drone, so we do it, and then the drone operator just drops everything and commits himself to the task to collect the data. Another issue is that it's quite difficult to find wild animals and collect the data on them. So we had to employ the hunter groups who actually provide us with the data from the feeding places, where they see from the cameras attached to the trees in the forest that there is animal movement in the areas, so we have to react as well very fast and drive to the place and collect the data from the air. So this is kind of, we knew it, but it's also kind of a challenge for in reaction time, and to collect the data is most essential in our use case.
That was very challenging. Thank you for sharing. In addition to the technology, let's talk about the people involved in the project. How have local communities or forest managers engaged with your work? What has their feedback been?
Mm-hmm. So I mentioned before, so that we have consulted the forest rangers, and this has been done during the various stages of our project development. So we presented the first results, what we actually got. We went to their gathering meetings and they presented where the infestation of the forest are. So we kind of discussed the possibility of technology application and how to cover the territories, how to collect the data and solve the issues and do apply preventive measures. So we kind of develop the decision process and preventive measures with them together, and as we see so fit that they could use the advancement of the technology. The later news were that one of the colleagues came by with the news and asked if we could do a specific targeted surveillance over the areas applied with the drones, and this is in the private forest area. So the private forest owners are also seeking advancement with the technology to actually seeking preventive fire starting in their forest, what preventive measures they could apply. And this means that we are suggesting the outcome of the project also suggests the preventive measures that we develop for the forest rangers and for the private forest owners, how they can tackle issues in their land. So yeah, it's local community, the governmental agencies and other institutions that see the project fit their purposes, how they can integrate technology and digitalize the processes to make it faster, more accurate, and save time and costs.
Thank you, Simonas. And that brings us to the end of this episode. Simonas, thank you once again for taking the time to be with us and share your valuable insights.
Thank you. Thank you for inviting me and share the experience from the project.
And of course, heartfelt thanks to all of our audience members. For more Icaerus news, don't forget to subscribe to our newsletter and follow us on social media. Until the next time, let's fly towards a more sustainable future. Thank you very much.